Hello and welcome to the visualino video tutorials. In this one we will start to get used to the different functions and working areas in the application, but also we will read analog values from the analog input of an analog sensor, namely an LDR, light dependent resistor that you can see connected and discuss on the course notes in the virtual classroom. So, as we are going to read analog inputs, we need some place to store them while we are handling them, and the right place is a variable. So we're going to make a variable by declaring a global one, give it a name, type in on that empty box, and an initial value that goes there. That's a number, and the math can be 0 because it's going to be updated soon. Now, this variable will be updated with the readings from the analog input. So we get our variable, we choose it from the pop-down menu, and we append this block to the previous one. They are going to be run sequentially, one after the other, as we move down. So as I was saying, this sensor variable will be updated with a new value. That's a reading from an analog pin, an analog read. That is under pin functions. So there we include the analog read pin and then the actual pin, which is an analog 1. Could be any from 0 to 5. Okay, and now we will like to watch them, the values that the sensor is getting on the screen of our computer's monitor. So that's a communication feature, and it's called a serial print. We are going to use serial print ln, so we get each value on a different line, which makes them easier to teleport. So we are going to serial print ln the variable itself. So we choose it. That's it. Now here we got like 3 lines with 1, 2, 3, 4, 5, 6 and 7 blocks, and this translates into this code. This wiring code on the right is what we would have typed it on the keyboard if we wanted to achieve the same result, meaning showing on a screen the values of the analog read on analog pin 0. As you may notice, there's a sensor variable being declared here and being given an initial value of 0. It's declared as an int, meaning an integer, because it's a natural number. So that way we are telling the microchip to book some memory space for that kind of numbers, and not any bigger or smaller. And then there, in the setup section, we got the A0 declared as an input, which actually shouldn't be necessary for an analog 1. But then there's also the serial begin 9600, meaning we are initiating the serial communication at this baud rate, meaning bauds per second. And then the sensor variable updated to the analog read from A0 values, and the printing on the screen in different lines of that value is inside the loop, the main program loop. The void loop repeats itself continuously, so we will be getting numbers on the screen as fast as these two lines can be executed by the microprocessor, which is really fast, and and sent to the serial port. As the serial buffer, meaning the memory space that will be getting those values, is a limited one, it will become saturated very early, and we will have our computer stuck probably. So we need to make things slow down a little bit, so we don't saturate the serial communications buffer, and for that we will use a control wait. Wait some milliseconds, the number and the math, like let's say 100. So this is wait 10th of a second, meaning nothing is going to happen during that, so the serial messages will be spaced by a 10th of a second, and that way we can read them and they won't saturate the serial buffer. So now we are actually going to upload that program into the microcontroller in the Arduino board. For that we need to select here the right model. We are using an Arduino01, and then the right port. As we connect the USB wire into our computer and the Arduino board, another port should appear here. It can either be an USB and then a 0 or a 1 probably, or an ACM0 or ACM1. Both of them are okay. That depends on the serial driver we are using in the precise board model. Now we click and choose this one, and then go and click on apply. Okay, there will be some warning errors. We are not impressed by them, and just wait till the making of the program evolves. So there is the sketch. This is its size, and then it tells us it's been finished. We should have seen the TX and LX with the transmit and TX and RX transmitting and receiving LEDs on the Arduino board blink a little before this finish appear here. And now if we click on monitor, we are going into the serial monitor, and those are the numbers I'm getting. So as I'm getting an analog input, that means I'm getting numbers from 0 to 1023 from the analog to digital converter inside the Arduino board. As I have my LDR connected to 5 volts and the resistor, the fixed resistor in the voltage divider connected to ground, maximum voltage could be at most 5 volts and minimum 0, so numbers will be in between. This number is the one corresponding to the ambient light intensity I got, and if I cast some shadow on the LDR, you can see the numbers are decreasing till they get to minimum as I get it as darker as I can. If I release my hand and let some light get into it, light intensity will grow, and so grows the input. So that let us like choose a level or a threshold, so we may have some reaction when there is a change in the light level. So let's say we want to control something by just casting a light shadow on the sensor. So I put my hand between the light on the sensor and see the numbers get below 700. So I'm going to use 700 as the threshold for some reaction, and that's going to happen in the next